So this is our CRO, right? So the zero setting is done, and we are checking whether our channel is in a proper uh, right configuration to accept our signal and give us proper reading. So this is our setting of the CRO where we have selected channel 1, and I have connected positive probe to this particular signal generated at this point by the CRO itself. So by default, it generates a square wave signal here of 0.2 volt peak to peak and signal frequency 1 kilohertz. So the purpose of this is to check whether your channel is working properly or not. So I could see that right now along the time axis or x axis, I have this 1, 2, 3, 4, 5. Okay, so if it is not exactly 5, then I have to make it exactly 5 if it is a short of the 5. So I'll go for this increase. So this is called calibration, right? So I'm doing the calibration now. It's exactly 5. Okay, so right now the time axis is managed. It is pointing at the 0.2, you can see, millisecond. Okay, 0.2 millisecond multiplied by 5 divisions, that gives me 1 millisecond, and uh, reciprocal of that or inverse of that is 1 upon time, that is 1 upon 1 millisecond is 1 kilohertz, that is provided by this particular connector. So this is self-generated signal from the CRO itself for the calibration purpose. And you can see that along the y-axis the amplitude is 1 division, and what is here, it is zero point 0.2 volts per division. So total amplitude is 0.2 volt, 0.2 volts, and the same it is supplied over here. So I need not worry about along the amplitude axis. Time axis I have already calibrated. Okay, so let me arrange for the CRO. So I'm connecting CRO over here, that is at the anode, and cathode is connected to the right negative terminal of the CRO. Now I am looking at the CRO end, so I am getting this particular signal. So you can check that. Okay, since the frequency is very low, so I am going for a ground over here. So I put it over here. I remove it here. So you can see the firing angle, right? The CRO, when it is fired, okay, its resistance drops to literally very low value. So the voltage across the CRO, you can see over here, it drops very close to 0 volt. It drops very close to 0. We have adjusted over here. Okay, so this is the firing angle. I could change the firing angle by manipulating the current or manipulating this potentiometer R2. So I'm changing this R2 so that I could go for the different values of firing. You can notice this. So I'm changing the firing angle. Okay, so if this is not changing much, you can change the frequency itself. Okay, so this is where you can go for the firing angles, changing very slowly. Okay, so you have noticed that by changing the pot position right over here, I could change this particular value, right? So this firing angle is changed. So right now the frequency is over 84. So you can see it takes some time for the firing. Okay. So what we are doing is that we are giving the readings of the small t, that is from this particular end to this particular end, and then we are taking with reference to capital T. So we can measure the firing angle of the CR. Okay, so this is the frequency. We could change the frequency. So let us say I could go for large frequency. Right, let us say 100. Now here I could change this. You can notice that there is a possibility of change. Okay, now if I want the firing angle beyond 90 degree, then I'm connecting this anode of the diode D1 to the capacitor in, because already D2 is connected in the picture. So only this single wire connection I need to make.